Howdy everybody in YouTube land. In this video we're going to take a look at a Sony power supply out of the SGI O2, otherwise known as the WeatherSTAR XL. Now, I now have two of these power supplies that are doing the same thing. And I'll have a separate video for each power supply, but for this particular power supply, this one right here was running fine on the SGI02, and all of a sudden it just shut off. There was no pop, there was no bang, there was nothing like that. It just turned off like you pulled the plug out of the back of it. So something failed silently in this power supply, so we need to investigate what that is. And replacing these power supplies is not exactly straightforward because of the funky 3.43 volts DC. Now, I got the cover off already. I'm going to start pulling this apart so I can get a better look inside and figure out what we got going on. But in the meantime, I did some quick research on the internet, and on the SGI forums, there's a user named Elf who posted some information about these power supplies, and apparently the red and the gray wire here, the red wire, and then there's a gray one right next to that. Those are the feedback wires. Those are the sense wires for the 0 volt and 3.43 volts, and they have to be looped out into the respective connections here because they're connected through the moose head back plane or front plane or whatever you want to call it. Because if you leave those floating, this power supply won't regulate. It'll just run wildly out of control and shut down. So that has to be taken care of. So in order to power this power supply up, I got to make jumper wires for that, but the power supply is not going to run anyways. So I got to get this apart and figure out what happened with the power supply. The other thing I wanted to note is they do have some quality capacitors in here, but they're old enough that I don't know how good they are. Now, those ones right there next to the heatsink, those are notorious for leaking, at least in the Macintosh LC power supplies. So, but even though this is a bit newer, that'll probably start leaking in the next few years. So they've got to go. They've all got to be replaced, just like my WeatherSTAR XL did. Now, this particular power supply was in a WeatherSTAR XL, so this thing probably got a decade of 24/7 use. So it's got a lot of hours on it, and it's going to need to be restored. So it's going to need all new capacitors. But before we even go down that road, we need to find out exactly what happened to it. So let's get this thing taken apart. Alright, now that I got the power supply apart, we can take a closer look and see what we got here. I don't see any evidence of capacitor leakage yet, but because this thing had a decade of 24/7 operation, it probably wouldn't hurt to have them changed, especially the ones that are closest to the heat sinks that can get baked to death. Because if one or two of those caps dry out, that would stop the whole thing from working. Same thing here. They put a cap right next to a heat producing transistor. That's just, yeah, that's asking for it. So, besides that, that is probably not why it quit working, but it's part of it. I'm taking a look at what circuitry we have going on here. So this chip here is the power factor correction PWM, which runs off, the drive signal runs off there and goes to the very first pin, which I'd have to chase that, but I don't feel like it right now. Let's see on the bottom, do we have any bad solder joints? No, not as far as I can tell. But, let's see, no. That looks a little suspicious. See that? That is metallization from an arc. Something arced between these two. So something got in this power supply. Now I don't know if that happened when it was new or what, or maybe that's why it failed. But this is the power factor correction, the PFC boost transformer. That's why this capacitor is rated for 450 volts, because this circuit here is designed to boost up the 160 volts mains into about 400 volts so the rest of the power supply can operate. I don't know the theory behind that. I don't know the math behind that on why it does it, but high efficiency power supplies, they do this. So you just have to be aware when you're looking at a power supply like this when you're troubleshooting, because if the PFC doesn't come up, the main PSU won't come up either. So we have the PFC circuit. This appears to be part of the standby regulator. So we have that at least. Now, I am not going to plug this power supply straight in and just troubleshoot it like, oh, well, let's measure the standby voltage or anything like that. I'm not going to do that with this power supply because I already know it doesn't work. But I just want to take these boards out and I want to inspect everything, because right now I can't get to anything underneath here. So I need to be able to get to the resistors and diodes. I need to get to that 2SC 4304 transistor that's in there. I need to be able to get to all of this. So in order to do that, I need to pull this board. So I think I want to go ahead and do that. But actually, before I do, I'm going to do a dry check on some of these transistors to make sure I don't have any that are short. The main line fuse appears to be good, but I want to check everything else real quick before I pull this board. So let's just do that. Alright, so I took the circuit board off, and I've been checking a lot of these capacitors that are, you know, right up against things that are suspect. So it's hard to do this on camera because of the way it's set up, but everything is fine. I don't have anything that's open. I mean, most of them are reading a little bit low, like just from use and heat and everything else. So they're all low, but they're not enough to cause this problem. However, I found something more concerning. This point on this transformer is open. I'm not seeing it on the circuit anywhere is a complete circuit. Like, for example, this is you can see the push-pull transistor pair here that drive this transformer. So if I check from here to here, let's do it right now. It's connected. But I go from here, it's open. From here, it's open. So I need to see if that is actually connected on this transformer, because I've never had this transformer out before. So I need to pull this transformer and verify the winding, because if that's open, that's a full stop right there. That's why it's not working, and it'll never work again if that's open. So let's check that first before I go any further. Alright, well, I got the transformer out, and in order to pull that transformer, I had to remove the heatsink assembly with all the rectifiers and transistors and stuff. So that's all out of there. So the good news is that winding does not exist. Even though there's a stake for it and there's a trace for it, it's not used. So that's a breath of fresh air. So there's only one primary winding that runs the power supply, and everything else is on the secondaries here. So that's fine. So I can set that off to the side, because I'm really glad, because that would have been a showstopper if that was bad. So good, all that's fine. So now I'm going to move on, and I'm going to start checking all of these to make sure that they're not shorted or bad or anything like that, because they're hard to test while they're in the circuit anyways. So now that it's out of circuit, it will be far easier to test. Then I'm going to go ahead and check all of these little components, because even though I don't need to remove them like that, it's easier to remove that stuff because I got to get the caps replaced anyway. But also, it's easier to remove these big parts out of the way to get to some of this stuff to actually physically check them, to look for open resistors or anything like that. So if none of the resistors are open, none of the diodes are shorted, none of the transistors are bad or anything like that, including this board, chances are the failure is likely one of these ICs or the opto isolators, because these ICs can silently fail and then the power supply won't run. And if we get to that point, then I got to put this all back together and do some live voltage checks to figure out which one of these has failed. So while I was in here, I decided to just go ahead and remove everything else off the board that's in my way to be able to check things. There's the PFC boost inductor that I removed. So there's a bunch of different, it's funny because there's a bunch of different connections in and out of that boost inductor. But if you look at it, there's only one winding on the boost inductor. So let's go ahead and check this boost inductor and figure out where we are with it. 320. It might as well be about 330 microhenry, which that sounds about right. The Q of 12, that thing's good. There's nothing wrong with that. So, which I didn't figure it would be bad, but never know. So I went ahead and checked that. It's fine. That's okay. This is the standby transformer, so I went ahead and removed it so we can see what's underneath there. So I will test U. There's multiple windings, especially on the primary side, likely because it's a blocking oscillator transformer. Uses a feedback winding, which makes sense because it's just its own little thingamabob. There's a current sense transformer, probably to monitor the current draw and regulate it that way. Okay, so let's see. You look like a good spot to test. Let's check you. You look fine. Now, this isn't obviously a foolproof test because this only reads the inductance of the transformer. It doesn't check for shorts. But what it does do is check if it's open, which it's not. Because an open transformer would prevent the thing from working too. Okay, we got one there. That's the primary side. That's why the inductance is so high. Nothing there. That must be a separate winding, which I bet it is. It's probably between here and here. Yep, it is. It's a pretty big one. 3 millihenries. Okay, so that's what we got. That transformer is probably fine, but I'll grab my ring tester and I will double check that. The next thing I want to do is simply check these power transistors here. We have a pair of 2SK 2543s, which are Mosfets, and then we have a pair of FK 10KMs, which I've never heard of. But I want to get a stand set up to check those, I think. Now, they make transistor testers, and I've seen so many videos with those in use, but I do not own one of those. I still do things the old school way, the way I was taught. And the easiest way to check those is, since this is a K, it's probably an N-channel MOSFET. So what we have to do is we have to check to make sure the body diode is present and there's no shorts. Yep, it's fine there. Fine there. Nothing, 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 nothing. So the next thing we do is, the way we check these is we charge up the gate of the junction. So if I measure between drain and source, I should get nothing, and I don't. But if my multimeter will actually charge up the gate. So if I just go between here and here, which I need both hands to do this, I can actually charge the gate and I'll get a measurement across the junction. So stand by. Alright, so here's my results. This diode's fine, the body diode's fine in all four of those. Now, if I charge the gate and then measure the junction, it drains off to high impedance really quickly. Now, a good MOSFET, it should, when you charge the gate, the junction should hold almost indefinitely. It may have very slow leakage currents, while all four of these have high leakage currents. So basically what a leakage current is, when you charge the gate, if there's any leakage between the gate and either of these junctions, the gate will slowly bleed its charge. And as it does, the resistance is going to go up on the meter, or your voltage drop, which is what I have that set for. And the fact that it is tells me there's high leakage currents on those gates. That may or may not be bad. Now, I can pull the data sheet of these transistors if I can find them, and double check them to see if there isn't any resistors already on the gate, because there might be an internal resistor between the gate and the source, right? So I need to check that, and if there isn't, chances are they're bad. They've gone leaky. The gates have gone leaky. That may or may not mean much, but it's probably not a good thing. However, we'll just make a little mental note of that, and then we'll move on. So the next thing I want to do is start checking all of these resistors and all of these diodes, and it's basically a shotgun troubleshooting approach before I plug things in the wall and watch things blow up in a ball of flames. So I'm going to go and check all of these resistors, and I'm going to look for ones that are open. I'm going to look for diodes that are shorted. I'm going to look for these transistors, if any of those are shorted, and on and on and on we go. So that's what we're going to do next. Alright, I went through all the components on this board besides the caps, which I did earlier. There's none bad. There's no open resistors, there's no shorted diodes. So this board is fine. Now I have to clarify something. I thought that was a current transformer. It's not. That is the drive transformer for the FETs. So the two FETs that are on this side, that's the drive transformer for those FETs. Where this one uses a discrete setup here, but this is a drive transformer, because if you see these two lines, they come up and they run in here, which goes over there. Then the other two runs off down into here and into this board. So the controller, one of these is responsible for the main power supply unit. So okay, that rules that out. So we have a proper circuit here. There's no issues going on besides, some slightly low value capacitors, but that's not causing our problem. There's a 3.3 volt low dropout regulator here. There's a thyristor over here, and it's fine. Everything's fine. I even checked these film caps with this guy for opens, and they're okay. So inductors, all that stuff, everything's fine on this board. So now I can set that guy aside. So wherever our problem is, it's not here. It's going to be in here. Or perhaps there's no problem at all, and it was the motherboard or the mezzanine board causing this. I doubt it, because he stuck another power supply in and it worked fine. So, okay. One of these is going to be a problem on this board, if anything. So we have a 3.3 volt, 12 volt, and 5 volt adjustments. Power factor correction, frequency adjustment, all that stuff's there. Here's the two. These can go bad sometimes and cause problems, because I've seen that before. So, okay. So now it's time to move on and check everything on this board as far as transistors and diodes and stuff like that. Anything that's not an integrated circuit, we'll check. Alright, so there's nothing immediately popping out to me as a hard failure. Now, I haven't gone through and checked every little surface mount resistor or anything like that, but I've quickly figured out how this power supply actually works. So this is the standby supply, which is self-oscillating, so that's pretty self-explanatory. So then we have the PWM circuit here, which is a switching regulator. That's the PFC boost circuit, which is run by this pair of Mosfets here and this inductor that goes there. That jumps up to your voltage to 400 volts. Now, this CXA8038 is yet another PWM switching regulator, which runs the main transformer and your positive 5 and your positive 12 volts. Or, well, 3.43 volts and 12 volts. So now, then on the other side, we have some LM324s, these are the Rome semiconductor versions of it. Then we have this IR3M02N, which is just a TL494 with a couple extra features, but it's basically a 494. And then there's the drive transistors for the 494. And if you've worked on car audio, you're pretty familiar with this circuit. I know I am. So that circuit sends a drive signal out to this MOSFET array here, which is the 5 volt switching buck converter. So it takes off the 12 volt tap, and then we got a transistor here that runs a 12 volt circuit there, but then this is the step down regulator. So we have the main inductor there, and then there's the rectifier diode back here, filter capacitor, and a filter choke, and it provides the 5.1 volts for the system. That's run off this buck regulator here. So we have all of that, and all of these voltages have feedback taps that go in here. And if any one of those does not start up for any reason, it's going to put the power supply into an error condition, of course. So I think also the main switching regulator does not turn on. It turns on through one of these opto isolators. So if it's bad, it won't come on, of course, because we have an on signal right here, which goes all the way down to this section there. So it also comes out here, which is a dead end. It doesn't go anywhere. So we've done our quick preliminary checks. There's no hard failures. So at this point, besides removing these guys and testing them in a breadboard, the only thing I can do now is put this thing all the way back together and get it into mains power and do some probing. See if we have standby voltage. We run a couple of jumper wires here as indicated on the SGI forums for the sense wires, and then we attempt to start it up and figure out which voltages are missing. We should get our 3.43. If we don't even get that, then the main switcher is not coming up. Then we got to probe and figure out why the main switcher is not coming up by looking at the reference design for this particular integrated circuit. So if this circuit's being told to come on, but it's not coming on, we know it's bad, right? Same thing with here. Same thing with all of these. The data sheets are available on all of these PWM switching converter circuits, so we can actually follow that data sheet and we can make a determination where the faults lie. So let's do that. Alright, we're going to get the explosions on cameras, or on this camera anyways. Got my meter probe on a 3.3 volt standby. I've got the 3.43 volt sense wired in. I've got the 0 volt sense wired in, so that's all done. There is no load resistors on this power supply, so it probably won't run right unless there's a load on it. But I got my power cord plugged in here, and this is kind of dangerous. So, and the meter's on, so here goes. I got 3.3 volts. So yes, I have 3.3 volts. So we have standby voltage. Alright, so the standby power supply shut down. So our issue is not related to standby. Alright, so according to this, we need blue ground to start, so we need to do that. But before I do that, I need to get a hard drive set up, some kind of a load here so we can run this thing. So let me go grab that. Alright, we're all rigged in with a sacrificial hard drive, so let's just plug you in. And then here we go. No. Nothing. So the main power supply does not start and run. Alright, so now we have a fault. We have standby, but we have no run. Nothing starts. Alright, so at least we have something to go off of. So I'm going to go ahead and move on from that. But I am going to try another hard drive just in case. In case this one needs like a spin command or something, I don't know. So I'm going to grab another one of those and just roll that out right quick. Alright, I grabbed another piece of crap sacrificial drive because I don't know if that other drive actually worked, but we're going to find out. Okay, let's try it again. I hate not having a solid core wire. Really? That one fired up. Power supply is running. Well then, interesting. That is an interesting observation. Let's plug the fan in. So I don't know why the power supply, he says it quit working. Now it might be quitting under full load, because anything is possible with that. Because of issues with caps and stuff like that, it could be shutting down under full load. Alrighty then. Well, okay. So did I tear this thing all the way apart for no reason? I don't know. Alright, I tore this thing all the way apart, didn't find anything, put it all back together, and it works. Don't ask me why. It just does. Alright, so now that the basic function test of the power supply has passed, and we know that it's functioning, I went ahead and ordered all new capacitors, and we're going to go ahead and recap this power supply so we can get it ready for the next, 10 years down the line. At least that's the hope anyway. So just go ahead and recap all of this and move on to the next one. If anything, out of all the capacitors that's on this power supply, this is the one that's going to give you the most grief. See how heat baked it is? It's right here. So this transistor gets hot and that cap is just, yeah, this is a 220 at 16, I think. Yeah, that's the one that's going to get heat baked. That's going to be your biggest problem out of all of them, but we're changing them all anyways. Be forewarned, when replacing this capacitor, which sits right there, there's a 390K resistor literally right across it. So when you wick up that solder, you'll knock this resistor off and lose it. So be very, very, very careful. Also, I had to go with full-size caps with some of these because it's getting much harder to find those low-profile capacitors anymore because there's not a market for them really, because they've been replaced with surface mount electrolytics. So yeah, you can make a surface mount work if you do some rigging, but yeah, luckily there's enough clearance I can just use standard caps and fold them over. And that's it. All of the capacitors have been changed. Again, with special care about this 390K ohm resistor that sits right there. So that's important. All done there, with the exception of this main filter because I can't quite get that size. The ones that I get are a larger diameter, which won't fit in here. I've not sourced a replacement yet. There might be one out there, but as the time of ordering the parts, I couldn't get this one, so I just left it alone. But all the other ones are done. The more important ones are done, especially down here next to the heat sources that tend to go first. Like that one and that cluster there. So time to put this thing all back together and hope for the best. Alright, she's all back together. I tried to lubricate the fan, but that is a sealed bearing. It's covered in plastic, so you can't. Yeah. Anyway, so the power supply is done. It's all back together. It's either going to blow up or it's going to work perfectly fine. Now, what I have over here is a parts machine. I don't know if it works, don't know anything about it. I don't think it's got a good motherboard. I think it's just parts, but the good news is I'd rather destroy a parts machine if something goes catastrophically wrong with the power supply than destroy my good WeatherSTAR XL. So I'm going to use this as a test base to see if the power supply works, because I don't even know if this machine works. I should plug this machine in and see if it actually turns on before I go down a rabbit hole. So yeah, let's do that. As you can probably tell, it's seen far better days. It's beat all the crap. It's done. So, alright, let's see if the original power supply works. It does. Well, red light, because bad motherboard. So yes, the power supply does run in this machine. That is the most important thing. Alright. Now this one has the... Yeah, that's strange. The pin's missing in that one. So that's going to be fun to remove. But anyway, so... Now or never. Does it work or does it not? Hey, it does. So we have a machine that now powers on. Now we've got a red light of death because it's a parts machine with a bad motherboard. But that's okay. For testing, it does what I need it to do. Alright. So we have a functional power supply. Now that I know it's not going to blow my machine up, I'm going to move that power supply into a working machine. But yeah, it's all good. Alright, so this machine runs, as far as I know. Still has the weather channel drives in it, so... same exact problem this one has. Ugh. Yeah, crap. That's a problem with brittle plastic disease. Yeah, there's no way to... Stand by. Yeah, that power supply is the exact same problem. The pin's busted completely off. Okay, so this is the device under test. The one that I recapped. You can see all the nice, pretty pink capacitors in there. So, alright. I know this machine runs. At least I think it did anyways. Who knows? Alright, here we go. No, it doesn't. Oh, yep, it does. Both lights are on. So it is running. Oh, I like that sound. So we have a fully functional power supply, ladies and gentlemen. Completely restored with fresh capacitors. Which I had no doubts it would work fine because my XL machine, I did the same thing to its power supply and that thing's been a trooper. So we are fully functional and we got a green light. So this machine is running fine with the rebuilt power supply. So we are ready to go. So this power supply can go back to its original owner and he can enjoy his machine once again. And if hopefully you learned something from this video. If not, well, at least you enjoyed the entertainment. If you have a comment, please feel free to leave one. And don't forget to hit the like and subscribe and all of that fun stuff. And thank you for watching. Until next time.